So last class we talked about the sampling distribution, right? Still remember what is the sampling distribution? We say we have a population, right? And then all possible samples with the same sample size. And then for these samples, we calculate the sample means, we calculate the sample proportions, and then based on the list of the sample means, we can get a distribution. We call this distribution is the sampling distribution of mean, right? And then based on the list of the proportion, we call it is the distribution of sampling the distribution of sample proportion, or we call it is the sampling distribution of proportion, right? And then based on this distribution, we say once these two assumptions are both satisfied, then we have these three properties, right? And then within these three properties, we say the sampling distribution of proportion will follow a normal distribution with the mean equals to the population proportion, the standard deviation equals to the square root of population proportion times 1 minus the population proportion divided by the sample size, right? So let's talk about this essay assignment 1. Here, the first question, what is the mean for the sampling distribution of proportions? What is the mean? The mean for the sampling distribution will be, this is the mean, right? Population proportion, right? The second question, what is the standard deviation for the sampling distribution of proportion? What is the standard deviation? This square root of PQ over N. This is the standard deviation of the sampling distribution, right? Okay, and then next question. What is the probability of observing a sample proportion that is at least 0.64? At least 0.64. It is the probability to the left or to the right? Anyone?
To the right.
To the right, right? At least 0.64. That means will be larger than 0.64. So you are looking for the probability to the right. So before you calculate the probabilities, before you know the mean and standard deviation of the sampling distribution, what do you need to do? Check assumptions, right? Before you can make sure both assumptions are both satisfied, then you have these properties, right? So this is the properties for the sampling distribution of proportions. And then we have another sampling distribution, which is about our sample mean, right? So we still need to check these two assumptions. This three properties, right? So we say the mean of this sampling distribution of mean, which is this is the mean of this sampling distribution. This is the standard deviation of this sampling distribution, right? And then we say, based on this sampling distribution, we can calculate the probabilities, right, to the left or to the right. But actually, this is not our goal for studying about the sampling distribution. We just say, once we have this sampling distribution, what we can do. But actually, for the sampling distribution, the goal is to find the relationship between the sample and the population. Between the sample and the population. Right, so based on this sampling distribution, we kind of get the relationship between the sample mean and population mean. We get the relationship between the sample proportion and the population proportion. Right, and then we want to use this relationship so that what if we have only one sample? How we can use one sample to estimate the population? Because in our real practice, it is not possible for us to collect all possible samples within the population. It is not possible, right? So actually in our real practice, we only have one single sample, and then we want to use this single sample to estimate the population proportion or the population mean. Then we want to set the relationship between the sample and the population, right? Just like we have the proportion, sample proportion will follow a normal distribution with mean equals to the population proportion with standard deviation square root of PQ over N, right? And we have the relationship between the sample mean will follow the normal distribution with the mean of this sampling distribution just equals to the population mean, and we have sigma over square root of N as the standard deviation. Right, we have this relationship, but we say once we have only one sample, is that possible that once we calculate the sample mean for this sample, can we just say, okay, I can use this sample mean to just say the population mean will be the same with mean? Can you see that? Of course not, right? So there will be something we call the sampling error, because based on different samples, we have different sample means, but the population mean is already fixed. So you cannot say that the sample mean will be just equals to the population mean. So once we have one sample mean, for example, we have the sample mean here, we want to give a distance or add a kind of sampling error to get the upper bound of the population mean. And then we minus another distance to get the lower limit of the confidence of the population mean, right? So that's from the lower limit to the upper limit, we call it is the confidence interval for the population mean, right? And then this distance, we just call it is the margin of error, another margin of error, right? So margin of error is what? Margin of error is actually the error we can allow from the sample mean to the population mean, so that we can be confident that from the lower limit here to the upper limit here, the population mean will be contained in this interval. We call this is the confidence interval. Similar idea, we have a sample. Based on this sample, we can get the sample proportion, right? We can allow a margin of error to the right, a margin of error to the left, right? So that we have the upper limit, the lower limit, and then we can be sure, or we say we have 95% confidence that the population proportion P will be contained in this interval. Then this is the confidence interval for the population proportion. Right, so this is the idea. And now we will use this relationship to get the confidence interval, right? Then we just say how to get this confidence interval. The first step is still check the assumptions. The assumptions will be the same for the proportion, independence assumption, normality assumption. For the mean, again, independent assumption, normality assumption, right? The only difference will be the normality assumption will be different. All right, and step 2 will be just a calculation, right? We say our idea is once we have a sample, it doesn't matter you have the sample mean or the sample proportion, we have an estimate for the population mean or the population proportion. So that will be the first part of the confidence interval. We have the estimate, but this estimate may not be accurate. That's why we allow some distance to the right, allow some distance to the left. We call it is the margin of error. So that's the general formula for the confidence interval is always the estimate plus minus the margin of error. Plus will be the upper limit, minus will be the lower limit. All right, so this is the general formula. Then we will again focus on these two summary statistics. Right, so it would be the proportion and the mean. What if I want to get a 95% confidence interval for the population proportion? This is the formula. All right, so let's look at this formula in details. The first, we say we have a sample, then the sample proportion will be our estimate, right? Okay, and then plus minus the whole part here will be the margin of error, we short for ME. Right? In some book, it also short for MOE. It's the same thing, margin of error. All right, so now we have the margin of error, and in the margin of error, do you feel familiar for this part? What is this? Still remember we have p hat follow normal distribution with p square root of pq over n, right? We call this is the standard deviation of this normal distribution of the sampling distribution of proportion. So this is the standard deviation. But when we want to know about the population proportion, that means the p here is unknown. Instead, we want to replace it with p hat. So that in the confidence interval, we have the square root of p hat times q hat divided by the sample size n. And this p square root of p hat q hat over n, we cannot call it standard deviation anymore. We call it is the standard error. All right, so that means based on a sample, I can get the sample proportion. I can get 1 minus the sample proportion. I can get the sample size n. That means the only thing you need is actually just a z star, right? So what is the z star? The z star, we call it is the critical value. Right. How we can find the value of z star? The z star is depending on your confidence level. Right, so here, this is the way how you find the z star. Use the confidence level, right? So we say if you want a 90% confidence interval, then your z star will be 1.645. If your confidence level is 95%, your z star will be 1.96. Right? If your confidence level is 99%, that means your z star is 2.576. You need to remember these values. Right. So whenever I say, okay, the confidence level is 95%, what will be the z? 1.96. All right. In your other courses, including the ISA 125, right, we can use either 1.96 or 2. But in our course, I want you to remember the detailed value of the z star, 1.96 for 95% confidence level, 1.645 for the 90% confidence level, 2.576 for the 99% confidence level. All right, so then that's it, right? So this is the way how you find the z star. That means once you have the confidence level, once you have the sample, you have all the information in this formula. That means you can calculate the confidence interval, right? For the proportion, for the population proportion. The other way, if we want to get the confidence interval for the population mean, similarly, we still have the estimate. Now it will be use the sample mean to estimate the population mean, right? So again, this x bar will be your estimate. And again, still remember we have x bar follow normal distribution with mu sigma over square root of n, right? So this is the standard deviation of the sampling distribution of mean. Right, so then we use the z star times the standard deviation when the sigma is given, when the population standard deviation is given. Then you will use this formula, the left formula. The other way, what if the population standard deviation sigma is not given? Similarly, I need to use the sample standard deviation instead of the population standard deviation. I will replace this sigma by the sample standard deviation S. But the difference is at the same time, you will not have the Z star anymore. You will have the T star. Right? Because once you replace the sigma by S, the distribution will change from the normal distribution to the T distribution, right? So that means if you have the sample, of course you have the sample mean, of course you have the sample size, right? You have this confidence level, that means you can find the Z star. So there's no problem when the sigma is given. But when the sigma is unknown, when the sigma is not given, that means you have the sample mean, you have the sample standard deviation, you have the sample size, but how you can find this T star? We say the T star will depending on two parameters. The first one will be the degree of freedom. Right, the other one is alpha over 2. You need to use both of these two informations. Go to the T table to find this T star, not just these three values like Z star. T star, you have a T table because the degree of freedom equals to n minus 1. That means it depends on your sample size. So whatever your sample size is, your degree of freedom will be your sample size minus 1. Right. The other thing you need to use is alpha over 2. So what is alpha? When we talk about the confidence level, right? So when we talk about the confidence level here, the alpha is actually the opposite of your confidence level. So we say we are 90% of the 90% confidence about our confidence interval, then you have 10% not confident about your results. Then your alpha will be 0.1. Confidence level 95%, that means 5% you are not confident. That means your alpha will be 0.05. 99% confidence, that means you have 1% not confident. That means your alpha will be 0.01. To find this T star, you are not using the alpha, you are using the alpha over 2. So that means you need to use, for example, if my n is, let's say 52, and my is I want a 90% confidence interval. That means to find this T star, you need to prepare the degree of freedom first, which is, what will be the degree of freedom? Abby? Abby, are you there? Abby? Abby? No. What is the degree of freedom, Ben? Ben. Okay.
Wait, are you talking to me? Wait, sorry, can you
So
repeat the
what
question? I
will
was
be the
just
degree? What is the degree of freedom in this case? We have the n equals to 52. We want the 90% confidence interval. Then what will be the degree of freedom?
is that just n minus 1 or
Right, so it will
okay,
be
so 51.
51. Perfect. All right, next question. What is alpha over 2? Let's say, Nico, what is alpha over 2?
0.05.
0.05, is that right? Yes, right. So we want 90% confidence interval. That means our alpha will be 0.1, right? 10%, which is
Could you
0.1.
go over the explanation of alpha one more time?
Alpha?
Yes.
Okay. Alpha will be the opposite or 100% minus the confidence level. So you have 90%, that means your alpha will be 10%. If your confidence level is 95%, alpha is 5%. 100% minus 95% will be 5%. Right? Confidence level 99%, that means your alpha will be 1%. So that means your alpha will be 0.01.
All right, thank you.
You're welcome. Right, so that means in our example, your alpha over 2 will be 0.05. All right, and then how we can find our T star with these two information? We go to our T table. Right, so the first page of our table is our Z table. We need to go down to our T table. So next page is our T table. All right, so let's review a little bit for the T table. The vertical axis is the degree of freedom, right? The x-axis is our alpha over 2, right? So in our case, in our example, we say our n is 52. We want 90% confidence interval. That means our degree of freedom equals to 51, right? So we just focus on 51 line. All right, combine with alpha over 2. We say alpha is 100% minus 90%, which is 10%, right? So which is 0.1 divided by 2, which is 0.05. So we just looking at, let me make it larger. Right, so we just look for T of 0.05, so we'll be here. So combined together, that means this 1.675 will be your T star. Got it? All right, so now let me change a little bit. Okay, so now I change my n to 32. And I want 99% confidence interval. Try by yourself. Again, I need you to turn on your camera so that I can see you. Right. If you haven't, please do. Thank you. All right. Olivia, what do you think? What will be our T star?
Is it 2.744?
How you find that?
The degree of freedom would be 32 minus 1, which was 31.
Okay.
And then our alpha was going to be 0.01, so I divided that by 2 to get 0.005, which brought me to the right to 2.744.
Perfect. Thank you. All right, so that will be your T star. Got it? All right, any questions? Okay, all right, let's move on to the next step. Right, so let's review a little bit, summarize a little bit. Right, we say for the confidence interval for the population proportion, we only have one formula, right? So we only have this p hat plus minus z star times square root of p hat q hat over n. So we only have this formula. But if you want a confidence interval for the population mean, then we have two options. You need to decide by yourself which formula you need to use depending on the population standard deviation is given or not. Right? So we say if the population standard deviation is given, then you have this formula. Then you have the z star. How you find this z star? In your mind, right? You need to remember them. 1.645, 1.96, 2.576. All right. If the population standard deviation sigma is unknown, then you need to use the S, which is the sample standard deviation instead. At the same time, the Z star will change to T star. How you find the T star? The T star will depending on the degree of freedom and alpha over 2. All right. Okay, before we start with our practice for computing the confidence interval, I want to talk about some comments for the confidence interval. All right, so confidence interval is not just two numbers, not just the lower level and upper level, right? You need to understand what is going on inside. All right, so first one, as what we said, right? So once we have a sample, right? Based on this sample, we can calculate the sample proportion or the sample mean, right? And then we want to allow some distance, we call it is the margin of error, so that we can get the upper level. And then we minus so that we get the lower level, right? We have the upper level, which is the p hat plus the margin of error. The lower level is actually p hat minus the margin of error. right? So actually, you have the relationship, which is the p hat is actually in the middle of your confidence interval, right? So that means I have the confidence interval for the population proportion. That means you can use this confidence interval to get the sample proportion and the margin of error, right? Similarly, for the sample mean, once you have the sample mean, you add a margin of error to the right, you minus a margin of error to the left, then you have this confidence interval for the population mean, and then one of the confidence, then you can also calculate the sample mean, you can calculate the margin of error, right? So let's do a practice. We say there is a error here, right? So here should be the mean, and here is also the mean, right? So we say given a confidence interval, for example, given 95% confidence interval of the population mean as 70 to 90, what will be the sample mean? What will be the margin of error? Can you get it? Colton, what do you think? Colton, are you there?
Yeah.
Yeah.
Um,
So what will be the sample mean? What do you think? We say we have a 95% confidence interval for the mean, which is from 70 to 90. Then what will be the sample mean?
is it 80?
80, right? Because what? Because the sample mean is in the middle of the confidence interval, right? So midpoint will be just 70 plus 90 divided by 2, which is 80. Got it? Thank you. All right, so now one more question. What will be the margin of error? Dominic, what do you think? What will be the margin of error? Dominic? Yes.
Sorry. The margin of error. So the margin of error is when
Look at this. So what will be the margin of error? Will be this distance, right? Or this distance. So it will be
it would be
from 80
it'd be
to
from
90.
yeah, it'd be from 80 to 90, so 10.
10, right?
Yeah.
Or from 70 to 80, it will be also be 10, right?
Yes.
Perfect. All right, thank you. Right, so that means from 70 to 90 actually covers two margin of error, right? So actually you can either calculate the sample mean first and then calculate this distance, the one distance for the margin of error, or you can use from 90 to 70, it covers two margin of error. So one margin of error will be divided by 2, so it will be 10. It doesn't matter which way you prefer. You prefer to calculate the sample mean first and then calculate the margin of error, or you can directly calculate the margin of error, right? It doesn't matter which way you prefer, as long as you can get the result out, right? So it will be similarly if I have a 95% confidence interval for the population proportion, 0.65 to 0.78. Right, so this will be about the confidence interval for the proportion. What will be the sample proportion? Phoebe, what will be the sample proportion? Phoebe?
Yeah, I'm not 100% sure.
Try it. The confidence interval from 0.65 to 0.78, what will be the sample proportion? You say the sample proportion is in the middle of your confidence interval, right? So your confidence interval is 0.65 to 0.78. Then how you can get your midpoint, which is your sample proportion? All right. Maria, what do you think?
Is it 0.715?
All right, how you got that?
I took the average of the 2 points, so 0.65 plus 0.75 over 2.
Perfect. Thank you. All right. One more question. What will be the margin of error? How you can get this margin of error? How to pronounce that? I say Sanaski, Sanasi. Is that right?
Sanasi.
Yes. Thank you. What will be the margin of error?
The margin of error would be 6.5 or 0.065.
0.065. How you get that?
I just did 13 divided by 2. Oh, well, 0.13 divided by 2.
Right.
Yeah.
Right. So actually how you get actually the distance, right? So it would be 0.78 minus this 0.65 divided by 2, right? Okay, because the distance from the lower limit to the upper limit will cover 2 margin of error, right? Divided by 2 will be 1 margin of error. Right. So let's continue for the next topic about the confidence interval. Right, so we say sometimes you want to adjust your confidence interval. You think maybe your confidence interval is too wide, you want to narrow it down, or you think your confidence is too narrow, you want to make it wider, right? Then we want to talk about how you can adjust your confidence interval. Right, so we say we have 3 formulas, right? So for the proportion, we have p hat plus minus z r times square root of p hat q hat over n. For the mean, we have x bar plus minus the t star. Let's use the z star first. We have 2 formulas for the mean, right? So x bar plus minus z star times sigma over square root of n, or x bar plus minus t star times s over square root of n. All right, so now my question is, if the sample size n increases, what will happen to the margin of error? It will decrease or increase? Anyone?
Would it increase?
It will increase. All right, why it will increase?
Is it because your confidence interval decreases?
Think about the formula here. The formulas here. We talk about when the sample size increases, what will happen to the margin of error. So which part is the margin of error? This part, right? So that means if you have a larger sample size here, the whole thing will increase or decrease?
Decrease.
Decrease, right? Because what? Because you are dividing by a larger value here, right? So that means if your sample size increases, your margin of error will decrease, right? If your margin of error decrease, what will happen to your confidence interval? Your confidence interval will be wider or narrower?
Narrow.
Narrower, because if your margin of error is smaller, margin of error smaller, means your confidence interval will be narrower, right? All right. Okay, next question. If the confidence level increases, what will happen to the margin of error? For example, your confidence level increased from 90% to 95%. Which one will be influenced by the confidence level? Jin?
Well, the margin of error would increase.
Margin of error will increase, right? Perfect, thank you. Right, so let's use the Z star for example, right? So we say this is the Z stars, right? And then we say if we increase the confidence level from 90% to 95%, the Z star will change from 1.645 to 1.96. So that means when the confidence level increases, the Z star will also increase, right? So if the Z star increases, that means you are multiplying a bigger value. So that will be the margin of error will also increase. The confidence level increases, the Z star will also increase. If the Z star increase, the margin of error will also increase. That means your margin of error increases. That means your confidence interval will be wider, right? Okay, the other way. What if your alpha increases? Still remember what is alpha? Alpha is the opposite level of the confidence level, right? So we say if the confidence level is 90%, that means your alpha will be 10%. If your confidence level will be 95%, your alpha will be 0.05, which is 5%, right? So that means if your alpha increases, for example, increase from 5% to 10%, that means your Z star will be decreasing. The opposite, because the alpha and confidence level is opposite trend, right? So the alpha and Z star also has the opposite trend. So in this case, when the alpha increases, the margin of error will decrease because the Z star will also decrease, right? So if the margin of error decreases, that means your confidence interval will be narrower. All right, so now we're kind of discussing all these options. Now, final question. If we want to decrease the margin of error, we want to make the confidence interval as accurate as possible, what options do we have? If you want to decrease the margin of error, what options do we have?
Grow your sample size.
You want to increase your sample size. Perfect. Any other options? Anyone?
Increase alpha.
Increase alpha. Perfect. Anything else? Similarly, decrease your confidence level. right, so that will be the ways or the options we have to decrease the margin of error. Right, so these ones are the influence factors of the confidence interval. All right, so after this, I also want to talk about interpretations of a confidence interval. Right, so in our real practice, it is not possible that you can just show, let's say, 0.70 to 0.90 to your manager and say, okay, here is the result. Here is the 90% confidence interval. Your manager may not be very familiar with the confidence interval, right? So these two values, you need to explain what does that mean, right? So that means we need to make the interpretations of a confidence interval you get. That will be your last step. You need to make your conclusion. All right, so here I list actually two good ways for the confidence interval. Right, so for example, I have a 95% confidence interval for the population proportion as 0.70 to 0.90. Then what does this mean? We can say we have 95% confidence that our interval contains the true population proportion. Right, this is one way. Another way will be just kind of a little bit different. We are 95% confident that the true population proportion will lie in our interval. Right, so kind of give a meaning to our results. Right, another one, actually it is an interpretation not for the detailed confidence interval. It's actually the interpretation for this confidence level 95%. What does this 95% mean? We normally say this 95% is our level of confidence, but what does this 95% mean inside? Right, so we say, remember in our sampling distribution of proportion, for example, sampling distribution of proportion, we say from the population, we select all possible samples from the same population with the same sample size, right? And then based on this sample size, based on these samples, we can calculate the sample means, right? And with different sample means, based on different sample means, we use this formula to calculate the confidence interval. That means, of course, your confidence interval will be different based on different sample means, right? That means based on different sample, I have the sample mean. Based on different sample mean, I can calculate the confidence intervals based on different samples. And this 95% means 95% of all possible samples with this sample size will produce the confidence intervals cover the true population proportion or population mean. 95% of these confidence intervals will cover the true population parameter, either the population proportion or the population mean. If it is a 95% confidence interval, then that means another 5% of the another 5% of the samples will generate a confidence interval not cover the true population mean or the true population proportion. For example, in this picture, you will see that we have 20 samples. And based on these sample proportion, right? One dot means one sample proportion. And based on these sample proportions, we can generate a confidence interval. And that means only this confidence interval didn't contain the true population proportion, only this one. So that means 1 out of 20, which is 5%, right? So it will be 5% of the confidence intervals will not cover the true population proportion. The other 95% will cover the true population proportion. So this is how we explain this 95%. All right. So the other 3 ways, I just want to talk about the wrong interpretations of the confidence interval. Right, the first one, there is 0.95 probability that the true population proportion will fall in this interval. It is not right. Right, we say there is no relationship with the probability and the confidence level. There's no relationship. Right, why? Once you have the sample, your sample mean is already fixed. Right? Based on this sample mean, your confidence interval is also fixed. So your population mean will either fall in your confidence interval or fall outside your confidence interval. There is no probability related with your confidence interval. It's either inside or outside. Right, so there is no relationship between the probability and confidence level. The other way, the 95% of the samples will have the sample proportion between 0.70 to 0.90. What's wrong with this? At the beginning of today's class, we say why we want a confidence interval. We want to use the sample to estimate the population, right? So we say the confidence interval is always about the population. It's never about the sample. Once we have the confidence interval, we always want to know what will happen for the population proportion or the population mean. We never use it to estimate the next sample or another sample, which is the next one. We are 95% confidence that another random selected sample will have the sample proportion lies in our interval. It is not right. Right, we never use our confidence interval for this sample. All right. So before we talk about determining the sample size, let's do some practice for computing the confidence interval. All right, so we'll use the same example as last class. All right, so say the last class we have the example, consider 400 students as the whole population. They were asked if they own a car, and 240 replied that they did. Now suppose you randomly select a sample of 35 responses from 400 students shown as follows. So we say we totally have 24 yeses and 11 no's, right, in the last example. So now we say if we don't know anything about the population, if we don't know about the population proportion, what we have is just the sample. So we say we assume, just to assume this is another question, right? So we say assume, don't know the population proportion. We don't know anything about the proportion. Instead, we only have the information about the sample. We say the sample proportion, which is, we have already talked about that, 24 over 35, right, which is 0.686. We have our sample size, which is 35. Right, so if we only have the information about sample, we want to get 95% confidence interval for the population proportion P. Right? What you can do with it. Step 1. What will be your step 1? Remember, check the assumptions. This is always your step 1. Since in the last class we have already checked the assumptions, we will not check it again here. All right, let's just go to the step 2. Step 2, we just follow the formulas to calculate the confidence intervals, right? So since we are looking for the confidence interval for the proportion, we have the formula that's P hat plus minus Z star times square root of P hat Q hat over N. Right? So we have our P hat, which is 0.686 plus minus Z star. Okay, Kenzie, is that right? Kenzie?
Yes.
Okay, so what will be the Z star? What is the value for the Z star?
Z star for 1.96.
Perfect. Thank you. So Z star is 1.96 for 95% confidence interval, right? Okay, and then plug in the values for the P hat, Q hat, 0.686 times Q hat, which is 1 minus P hat, 0.314, divide by the sample size, which is 35. And then after calculation, you have 0.686 plus minus 0.153, and then you can convert it into the confidence interval format, right? So 0.68 minus 0.153 will be the lower limit, which is 0.533. All right, and then 0.686 plus the margin of error. So this will be the margin of error, right? So it will be 0.839. All right, are you done? Of course not. Right, you have one more step. Interpret your confidence interval. We say what? We say we are 95% confident that the true population proportion, in our case, it is the proportion of owning a car is contained in the interval of 0.533 to 0.839. All right, and then we are done. All right, so this is the way, if we have the sample, how we can get the confidence interval for the population proportion. Similarly, for the next example, right? So we say, according to the Gallup poll, 27% of United States adults have high levels of cholesterol. And this report has been a major concern to the health insurance providers. According to the recent studies, cholesterol levels in the healthy United States adults average about 215 with a standard deviation of 30. And if the cholesterol levels of a sample of 42 healthy United States adults is taken, then what is the probability, right? So the probability will be the question of last class, right? So in this class, suppose we don't know about the population mean. We don't know the population mean is 215 or not, right? Based on this sample, I want to get a confidence interval for the cholesterol level in the healthy United States adults, right? What should we do? Right, so let's start. Right, so we say assume, right, in this question, just say assume the population mean is unknown. Right? So instead, we have the sample mean, which is 200. We have the sample size, which is sample size 42 of them, right? And we have, let's say, the population standard deviation is given, right? So in this case, the population standard deviation is 30, right? So that means the population standard deviation sigma is given. All right, and then based on this information, I want to get a 99% confidence interval for the population mean mu. You can calculate the step 1. Always assumptions, right? Since last class we done that, so let's talk about step 2. Right, step 2, that means you need to use the formulas to get the confidence interval. Which formula you need to use? For the confidence interval for the population mean, we have 2 formulas, right? X bar plus minus Z star times sigma over square root of n, or X bar plus minus T star times S over square root of n. Right? So which one? Number 1 or number 2? Kitty. Kitty?
We would use 1
Use 1, right? Because
because the thing is given.
yes, because this population standard deviation is given, right? Thank you. All right, so we are using this formula Z star times sigma over square root of n, right? So we have X bar, which is 200 plus minus Z star for 99%. Let's say Murray. What is the Z star for the 99% confidence interval?
2.576.
Perfect, thank you. Right, times the sigma, which is 30 over square root of n, which is 42, right? So we can calculate this, which is 200 plus minus 11.92. We change to the format of interval, so we have 188.08 to 211.92. All right, so then next step will always be the interpretation, right? So we are 95% confident that the population mean of the cholesterol level of United States adults is contained in the interval of 188.1 to 111.92. All right, so we are done with this question, but my question changed a little bit. What if this 30 is not a population standard deviation? What if I just give you a sample, and this sample, I have sample mean is 200, I have the sample size is still 42, and now this 30 I change to not the population standard deviation, instead it is the sample standard deviation. I still want a 99% confidence interval for a meal. Again, nothing will be changed, only for the formula, in this case, the population standard deviation when it's not given. That means you need to use x bar plus minus t star times s over square root of n. If this 30 is a sample standard deviation, then you need to change to another formula, right? So we have still 200 plus minus t star times the s, which is 30 divided by square root of 42. The only thing left is to find the value of t star, right? So what is the t star? We need two information, right? Degree of freedom n minus 1. So it will be 42 minus 1, 41. Right? Another one, alpha over 2. So that will be, we want 99% confidence interval. That means alpha will be 0.01 divided by 2. So that would be 0.005. Right? And then we need to go to the t table. We say the degree of freedom is 41. The alpha over 2 is 0.005. What will be our t star? Zhongji. Is that right? Zhongji.
Yeah.
Yeah. So what will be the t star?
It's 2.701.
So all right. How you find it?
The degree of freedom is 41, and alpha divided 2 is like
0.005, right? Okay, combined together would be this, which is our t star, 2.701, right? Okay, now let's come back. That means we can replace this t star with 2.701, and then we can just calculate to be 187.5 to 112.5. Got it? Any questions? Oh, good. All right. So next step, I want to show you how to get the okay. Next step, I want to show you how to calculate or get the confidence interval from the jump by jump. All right. So go to your module 1 page. Right, in the module 1 page, after the class notes, there is a data set called the break case stopping distance. Click that and download. Right, and then open it in the jump. Right, you should have this. You should have this data set. Everyone has it? All good? All right, so now we have a detailed data instead of just telling you what is the sample mean, what is the sample size. Actually, you have the detailed value for every observation in the sample. All right, and then from this sample, we can see that, okay, we totally have 81 of them. So that means our sample size is 81. So normally what we do by hand, we just average these values to get the sample mean, and we have the sample size, all right? And then we can calculate the sample standard deviation. But actually, in the jump, we do not need to do so, right? So we have the function, you click the analyze, and then distribution. Right, since we want to get the confidence interval for the stopping distance, just pull it to the Y. Click OK. Right, you should have this output. All right, and this direction looks weird, so let's change the direction by clicking the red triangle and then stack. And then you should have the direction that you're familiar with. All right, okay, now in the default output, you will have the upper 95% and lower 95%. So this is a confidence interval, 95% confidence interval for the stopping distance. All right, and then what if I want to change my confidence level? Another red triangle beside the stopping distance. All right, and then in the following options, there is one called the confidence interval. Right, choose the other. Right, so in this option, here you can change whatever the confidence level you like. Right, so 0.90 or 0.80, 0.75, whatever you like. All right, and then here there is another option called use known sigma. What does that mean? That means in the default, we are using this formula, assuming that we do not know the population standard deviation sigma. Right, but what if I know the population standard deviation? That means that will be better, right? So we need to enter that information. So if we know the population standard sigma, click this option and then click OK so that you can enter whatever the population sigma is, right? Population standard deviation. So for example, if I know the population standard deviation is 6, then click OK. Then JUMP will generate another column which is called the confidence intervals. And this confidence interval is a 90% confidence interval, 1 minus alpha, right? 90% confidence interval with the population standard deviation sigma equals to 6, and the lower confidence interval for the mean, the upper level of the confidence interval for the mean. So you will see there is difference between the default and the one we create. All right, okay, so this is the way how you get the confidence interval. But what if I do not have this detailed values? Instead, we just have the whatever we had in the example. For example, this example, we only have the summary statistics like the sample mean, the sample size, right? Then what should we do? The JUMP can also do this work, right? Click help. All right, and then there is one option called sample data. Be careful here, it's not the sample data library, it's the sample data. All right, click this sample data. Right, at the bottom, there is one option called the calculators. Click that red triangle, not red triangle, just triangle here. Right, you will have the calculators for all of these options. We will use all of these options this semester. But for now, we only have the confidence interval for one mean, the confidence interval for one proportion. Right, so let's do an example like this example. Right, okay, so we say we want the confidence interval, 99% confidence interval for the population mean. So that will be the first option. Since we do not have the raw data, we have the summary statistics. We just choose the summary statistics, click OK. Right, there is one screen that you need to enter all the information you need. Right, so in the first example here in our notes, not the first, just the mean example, right? We first assume we know the population standard deviation equals to 30. So that means your sample average is 200. Population standard deviation 30. sample size, which is 42, and I want to get a 99%, so it would be 0.99, right? Enter. Right? You will have your confidence interval, which is 188.8, right? Another one is 211.92, exactly the same. All right, but what if, for the second case, what if I do not have the population standard deviation? Instead, I have the sample standard deviation. That means I need to choose the interval type from Z to T. Once you choose this T, you will see that this option changed to sample standard deviation. That means you need to enter the sample standard deviation here. And then for everything else the same, you will have the upper limit, lower limit, which is the same with our result. Got idea? All right. Okay, so you may ask that why we need to learn all of these steps and calculate by hand, why we don't just skip these steps and then just use jump, right? You will have your future courses, right? So in your future, you will not limit to use the jump, right? You need to use R, you need to use SAS, you need to use what other else, right? Other softwares, right? You need to know what is inside of these functions so that you need to know why we need to enter that value, why we need to change from Z to T, right? So we still need to learn what is inside. We just provide the jump so that you don't need to vary a lot if you have a long data set, right? So in our exam, you still need to calculate by your hand, right? But in your project, you will be asked to use the jump to provide all your output so that you can have your conclusion, right? So we need to learn both sides. All right. The last thing I want to talk about is determining the sample size. All right, so for this part, there's nothing special. We just have two formulas, right? One formula for this sample size for the proportion, another sample size for the mean, the population mean, right? So similarly, we have these two cases, and then you need to determine the sample size. Before we have the true sample, you want to know what will be enough sample size. For example, I want my confidence interval as accurate as possible. That means you want the margin of error as small as possible. That means before you calculate your confidence interval, before you do something else, you want to limit your margin of error. Right, so sometimes in your question, you may see that I want to get a sample size so that a minimal sample size so that my confidence interval for the population mean is within plus minus let's say 0.2 of the sample mean, something like that. Right, so what does that mean? What is this 0.2? We say once we have the sample mean here, within plus 0.2 minus 0.2, that will be the confidence interval for the mu. So that means this 0.2 is the margin of error given to you. Right, so when you want to calculate or determine your sample size, you need to know what is your margin of error. It will always be given to you. Right, so you don't need to worry about that. You have the sample proportion, you have the 1 minus sample proportion, you have the Z star depending on the confidence level. So you have everything, you just follow the formula, right? So again, for the determining the sample size for the mean, you still have two formulas for the two cases, right? So the sigma and S. Right, since we do not have the T star anymore because the T star depending on the sample size, right? So that means you do not have the t, you don't need to change this z star to t star. You still have the z star. All right, so today I think we are done, and let me know if you have any questions. If you don't have any questions, you can leave and